All right, take a look at number 5. In this situation, we have a polynomial with 4 terms, right? We have one side set to 0, so that first step is complete. But we have a polynomial with 4 terms. And so this is not a quadratic, right? Because we have a third degree x term there, which means it's a cubic. And so we'll treat this one a little differently, right? We don't use our simple quadratic or complex quadratic factor, and we can use grouping, right? Since it has 4 terms, at least we can try it. That's the one that would best fit. So I'm going to check for GCF between all 4 terms, and I don't see any numerical GCF bigger than 1, right? That's a high, because we have a 1 there, and then they don't all have an x in common, right? 4 doesn't have an x, so there's no GCF that all 4 of them have in common. So now I'm going to try the grouping method. So I'm going to group the first 2 terms and the second 2 terms together, and then factor out the GCF there. So the GCF between 2x cubed and x squared is going to be x squared, right? And then the leftovers there will be 2x minus 1. Okay, and then here I'm going to do the same thing. Since there's a negative here, I'm going to factor out a negative. And the GCF between 8 and 4 is 4. And then if I divide both those by negative 4, I'll get positive 2x minus 1. All right, so now we can see that we have a common factor here in that binomial. So we can bring that to the front. And then we have our leftovers back here, x squared minus 4. All right. Okay, so now we want to just check to see, can we factor anything else, right? So the 2x minus 1 we can't do anything with because it's not a difference of 2 squares, right? So that's ready to solve for once we get to that stage. But x squared minus 4, that's a difference of 2 squares, right? So we can factor that more. So I'm going to bring down the 2x minus 1. And then for the x squared minus 4, I'm going to open up 2 more sets of parentheses, right? So I'm going to take the square root of x squared, which is x, put that here and here. It's a difference. And then I have another perfect square, 4. The square root of 4 is 2, so we put a 2 here and here. Do a plus and a minus. Okay, and now we're ready to solve, right? And so we can set these equal to 0. And I'm okay with you taking some shortcuts from this point here to the answer. If you can see some patterns of, hey, every time this is happening, right? Like for example, with these ones that just have 1 number here, really all that's happening is the signs are changing, right? So if you have x plus 2 here, of course it's going to take a negative 2 for x to make that turn to 0, right? So if you just realize that there's just a sign change, that you just get the opposite of whatever that number is, that's something that I'm okay with you going straight to the answer on. Okay, same thing here, right? So positive 2 minus 2 would equal 0. So you can just go straight to saying x equals 2. Or, if you need to, just solve the equation, add 2 to both sides, and that gets you there too. So it's always okay to show the work, but on these questions you can go straight from this step here to the answer. Okay. Now this one's a little different because it has the 2 in front, but I think you can figure out the pattern here too, and I'm okay with you going, with you jumping to the answer in this case as well. So here we would get 2x equals 1, and then we would divide both sides by 2. Running out of room here. So we get x equals 1/2, right? And if you notice, what happens is the numerator is the opposite of this. But then if you have a number here, that becomes your denominator, right? So it's positive 1 over 2. So that's a shortcut there. All right, so use the shortcuts if you're comfortable. If not, definitely showing the work is more than okay. All right, number 6. Now here we have fractions. And so the way that we can deal with those is, because we haven't really factored when we have fractions, right? Usually we're used to having integers in front and usually a positive value for a. So remember, we can, if we have an equation, we can eliminate the fractions by multiplying by the common denominator. And so the common denominator here between 12 and 6 and this invisible 1 here would be 12, right? So if I multiply 12 by this whole equation, right, then that'll get rid of the fractions and put me in a good position to factor. So I'm going to multiply by 12, but I'm just going to write the 12 for each term, just so I can do some individual canceling. And I do have to multiply the 12 on the right side by 0, but that's just going to turn to 0, right? So it's kind of a technicality, but make sure you know that we want to balance the equation. So here the 12s cancel out, so I'm just going to end up with 1x squared, right? Here, 12 over 6 is 2. 12 divided by 6 reduces to 2 over 1, or just 2, so we just get plus 2x. And then here, negative 2 times 12 is negative 24. Okay. All right, so now we have a simple quadratic. So we went from maybe a scary looking fraction heavy problem to a pretty mundane simple quadratic. So we're going to put an x here. We're looking for numbers that we can multiply to get 24 that we can subtract to get 2. And so 6 and 4 come to mind for me. So 6 times 4 is 24. 6 minus 4 is 2. This is the sign of the bigger number, so I'm going to put a positive there. Since this is negative, that means our signs are different. So I'm going to put a negative here, okay? All right, and then now we can go straight to the answer. So if you see it, you can just say, oh yeah, it's going to be the opposite of this, right? So negative 6, because negative 6 plus 6 would be 0. And then the opposite of negative 4 is positive 4, so it would be x equals 4, because 4 minus 4 is 0. So those are two possibilities, and that's how it's done. All right, and then the last one here, number 7. So here we have decimals. First thing before I deal with or actually, I guess you can deal with the decimals at any point. You could, let's do that first, actually. So remember, when we have decimals, we can multiply by some power of 10, right? And so in this case, since we have 2 decimals is our the most amount that we have, we can multiply by 100, and that will turn those decimals into integers, okay? So I'm going to multiply everything by 100, which means basically I'm just going to move the decimal. Let me just put 100 here. I'm going to multiply everything by 100, which basically means I'm just going to move each decimal 2 spots to the right. 1, 2, 1, 2, right? And so we'll end up with, there'll be a 0 here. So we'll end up with 2x squared minus 19x equals 10. All right, and we have to get one side to be 0. So I'm going to subtract 10 from both sides. So I get 2x squared minus 19x minus 10 equals 0. Okay, and then from there, we got one side to 0. So now we can just focus on factoring this side, just like we've done before. There's no GCF bigger than 1 here. And so I'm going to have to use my complex quadratic method. So I'll multiply 2 by 10, get 20. So I'm going to find numbers I can multiply to get 20 that I can subtract to get 19. So 20 and 1 come to mind on this one, right? And so those are my 2 values. So I'm going to put them in parentheses here. Leave a little space in front of the x for the coefficient to come. So it'll be 1 and 20. Okay, this number is the sign of this sign is the sign of the bigger number. And then this sign tells me that the signs are going to be different. So that means the smaller number is going to be different than the bigger number. All right. And so now I need to put whatever a is underneath. Okay, then we can reduce. 1 over 2 can't reduce, so that's good the way it is. 20 divided by 2 is 10. Or 10 over 1 if you want to put a 1 on the bottom. Okay, And then so now we take those reduced denominators, move them to the front. Numerators stay where they are, so it becomes 2x plus 1. And then here we get 1x minus 10. All right, and so once again, if you can go to the answers, that's great. So x equals 10 is the easiest one, just change the sign there. And then here, let's try to do this in our head. So we would change the sign here, that'd be -1. But since we have a number in front, a coefficient, that becomes our denominator, okay? So opposite of this over whatever this is. There we go.